This is the floating point rounding errors activity. This is for all languages. I'm going to do this one in C#. You can use any language you want. The problem exists in all 4 languages, but I'm going to use C# here. I've got a Visual Studio solution open, and I just added a test project that we can use to kind of explore this a little bit. I do recommend doing the research on your own. Kind of dive into this. Go do an internet search, do an AI search, try to learn more about floating point rounding errors activity, how they happen, how you can avoid them. We're going to use some code to explore this a little bit and build on, hopefully, the research you've already done. So I'll start off with a test file. I've got a test file open here. And we'll create a test method. I'm going to start with just doing a basic R equal method. And we're going to add 2 numbers together. We're going to compare it to a third number. So we'll say var A equals 0.1, var B equals 0.2, var C, which would be the sum of those, is 0.3. And let's just assert that C equals A plus B. So let's run this really fast. There we go. And we get a failure. And what it's saying is the value 0.3 does not equal 0.3000004. So what's going on? A plus B did not come out to 0.3 as we thought it might. This is a floating point rounding error. And again, once you've done your research, there's a lot of details about why this happens and how it happens. But this is a problem with all floating point numbers. Any mathematical operations can result in rounding errors in the floating point numbers. Whether they're singles or doubles, floats have this problem. So what are we to do? So there's a few different things that we can do here. The first is, I'm going to copy this test method. This one's going to continue to fail. Let's assume that it's close enough. And sometimes this is the case. If we're not terribly worried about being exact, we can call it close enough. And a lot of times, so in this case, assert or equal, we'll have a delta that we can use. The delta is the difference that we're allowed to have between the values. So I'll say a delta of 0.0001. So as long as A plus B is within 0.0001 of C, this test will pass. So let's see what this looks like now. We'll run R near. And that sure enough does pass. So we can say, look, it's still not the same, but it's close enough to be the same that we will leave that alone. So that's one thing that we can do. Another thing that we can do is we can actually round to the values. So let me copy the first test again. And let's say this test is with rounding. And here what we'll do is we'll use the rounding function in C# that's on the math class. And every language has a round somewhere. Usually it's a math class association, but we'll just call math.round, and I'll give it 2 to go to 2 decimal places. So now we'll see, does the rounded value of A plus 2 equal C? So let's run that. And sure enough, we get a pass. So that works as well. There's another thing that we can do. Instead of rounding, because sometimes that could cause some problems for us, generally it seems like it would be okay, but there are times where that doesn't work exactly. We can use a different data type. So let's do this one as with decimal. So we'll convert these values, instead of being doubles, which is a double floating point precision number, instead of using doubles, we're going to use decimal values. And most languages have some sort of decimal value that supports it. Sometimes you have to import it with a library. In C#, we can specify a decimal by suffixing a number with the letter M, the lowercase letter m. M means decimal. I don't know why M, but it means decimal. Now that we've got these, I hover over var, you'll see that it's a system.decimal instead of a system.double. So we're using a decimal data type with the exact. So running this test now, let's run it. And sure enough, it passes. So the reason the decimal type works has to do with how it stores values. If you're dealing with money and currency, generally you want to convert those values to decimal instead of doubles. Doubles can still be useful for things like distance, especially when we're not terribly worried about the exact accuracy of the numbers, rounded out to multiple decimal places. But that basically covers some of the options that we have available to us when dealing with floating point rounding numbers.